Before we dive deeper, Beyond Yacht is where owners and industry professionals come for the truth. Subscribe now to never miss a market deep dive.
So today we are looking at a case study in industrial risk. And usually when we talk about maritime engineering on this deep dive, we are talking about a specific vessel, like a single one-off prototype.
Right, a unique build.
Exactly. But today we are looking at what I can only describe as a, manufacturing anomaly. We are looking at a moment where a shipyard that was mostly known for building, fiberglass luxury boats decided to wake up one morning and just challenge the Northern European heavyweights at their own game.
Yeah, the Germans and the Dutch. It is effectively a story about hubris that, against all odds, managed to pay off.
Yeah.
We are talking about Benetti's Giga season.
Right, the Giga season. And just to set the context for everyone listening, if you know the industry, you know Benetti is Italian. They are legendary, sure, but historically they are the kings of the 40 to 60 meter semi-custom market.
The white boats you see in the Mediterranean.
Exactly. But if you wanted a 100 meter steel monster, you didn't go to Italy. You went to Bremen or Hamburg. You went to Lürssen or Feedship.
Precisely. Because the 100-meter plus category, what we call the Giga yacht segment, is an entirely different sport. It is not just boat building anymore.
It's heavy industry.
It's heavy infrastructure projects. Honestly, it's closer to building a skyscraper than a boat. And Benetti didn't just decide to build one to test the waters.
No, they didn't.
They signed contracts to build 3 of them simultaneously.
Which is, that is the part I really want to scrutinize today. Building 3 vessels over 100 meters at once. We're talking about Luminosity, IJE, and Lana. That isn't just a big order book.
No, it's a logistical nightmare waiting to happen.
Right. If you screw up the supply chain on one of these, you potentially cascade delays across all 3. You could literally bankrupt the yard.
It was an existential gamble for Benetti. We are talking about thousands of workers, millions of man-hours, and a complete ground-up overhaul of their industrial footprint in Livorno. They had to prove to the market that they could handle that level of complexity.
So, here's the plan for today's deep dive. We are going to strip down these 3 vessels, Luminosity, IJE, and Lana, or MAR, as she is called now.
She was recently renamed, yeah.
Right, renamed MAR. But I don't want to just, list the luxury amenities for you. I want us to understand the engineering delta between these 3 ships, because they are radically different.
Very different briefs from the owners.
Exactly. We have one that is essentially a floating glass structure, one that is a hardcore global explorer, and one that is basically a high-efficiency charter factory.
A hospitality machine.
Yeah. And then, at the end, we need to assess the Giga season itself. How did Benetti actually pull this off without the wheels coming off?
It's a good roadmap,
Yeah.
because each of these 3 sisters represents a very different engineering thesis.
Let's start with the most technically volatile one, Luminosity.
Ah, yes, Luminosity.
107.6 meters long. The source materials keep referring to it as a palace of glass. Now, in architecture on land, glass is incredibly common, but in naval architecture, glass is usually the enemy.
It is the absolute enemy. The fundamental problem with a ship's hull is that it is a dynamic beam.
A dynamic beam. Explain that for the listener.
Sure, so when a 100-meter steel structure rides over an ocean wave, it sags and hogs. It flexes. The ends might be supported by 2 wave peaks, while the middle sags into a trough.
So the whole ship is bending.
Exactly. It's bending and twisting. Steel is ductile, meaning it can handle that stress that stretches and rebounds. But glass is brittle. If the steel frame twists and the glass pane inside it is rigid,
The glass just shatters.
it explodes, yes.
So traditionally, shipbuilders use small windows, or they use massive steel mullion, like heavy frames, to isolate the glass from the movement of the hull.
Correct. You create a floating frame with flexible sealants so the steel hull can literally move around the window without putting pressure on the pane itself. But the owner of Luminosity didn't want that.
No heavy steel frames blocking the view.
Right. The brief was for 811 square meters of exterior glass. That is over 8,700 square feet of glass.
That is insane.
And with 3-meter high windows that are completely uninterrupted.
So they essentially wanted the glass to act as the wall of the ship.
Even more than that, they wanted the glass to be part of the actual structure.
Which seems impossible.
It required a massive research and development phase. Benetti had to collaborate with Ghent University and a specialized firm called Multi-Engineering to develop a completely new protocol for load-bearing glass in a marine environment.
Load-bearing implies the glass is actually helping to stiffen the ship. How is that even possible? If the ship flexes, the glass has to take that stress, right?
It all comes down to the adhesive.
The glue.
Yes, the glue. But not your standard marine caulking or mechanical fasteners. They had to develop a highly specific bonding process using a thick, high modulus epoxy adhesive.
Okay, so how does this epoxy work?
The idea is that the adhesive needs to be stiff enough to actually transfer structural loads between the steel superstructure and the glass panel. It turns the window from a weak point into an integral structural membrane that adds stiffness to the ship.
But if it's too stiff, the glass breaks when the steel expands.
Exactly. Steel expands in the heat of the sun. So the epoxy also needs just enough elasticity to absorb that thermal expansion without shattering the paint.
It's a chemical engineering problem just as much as a structural one?
Absolutely. And think about the safety margins you need for this. If a window blows out on a skyscraper, it's terrible, obviously. But if a window blows out on a ship in the middle of the North Atlantic,
You are taking on ocean water. You could sink.
you lose watertight integrity.
Yeah.
So Lloyd's Register, which is the classification society that insures and certifies these vessels, they had to sign off on this totally novel concept.
That couldn't have been easy.
It wasn't. They had to prove that even if the glass somehow fractures the laminate inner layer,
The plastic sheet sandwiched between the layers of glass?
right, that inner layer would hold the structural integrity together and keep the water out.
I assume they aren't using standard window panes you'd find on a house.
No, this is extremely thick, multi-laminate, chemically toughened glass.
Right.
But there is a secondary engineering challenge that comes with 800 square meters of glass.
Let me guess. The greenhouse effect.
You got it, the greenhouse effect.
Right, because you were basically building a floating terrarium and parking it in the Mediterranean sun in August. The heat gain inside that yacht must be astronomical.
It is massive. And this is where the engineering of the glass interacts directly with the mechanical systems of the ship. You can't just put clear glass up. If you did, you would literally cook the occupants inside.
So it has to be treated.
Yes. The glass on Luminosity is double glazed, and it uses highly advanced solar reflective coatings. But even with all that mitigation, the HVAC load, the air conditioning demand is tremendous.
Do we have a number on that cooling capacity?
We do. The cooling capacity of the HVAC system is approximately 3,000 kilowatts.
3,000 kilowatts just for air conditioning.
To put that in perspective for you, that is roughly equivalent to 850 tons of refrigeration. You could cool a mid-sized suburban shopping mall with the AC units installed on this single yacht.
That is a staggering parasitic load. I mean, you are burning massive amounts of diesel fuel just to keep this glass box habitable for the guests.
Well, that perfectly brings us to the propulsion system, because Luminosity attempts to mitigate that huge carbon footprint, or at the very least her acoustic footprint, through a massive hybrid system.
Okay, hybrid. Hybrid is such a buzzword in the industry right now. Every press release says hybrid. Are we talking about a Prius situation where the battery just helps you accelerate a little bit? Or is this a genuine fundamental electrification of the ship's propulsion?
This is a serial hybrid architecture. It is genuinely robust. The core of this system is a 3 megawatt hour lithium polymer battery bank.
3 megawatt hours. Okay, let's contextualize that. A standard long-range Tesla Model 3 is about 75 kilowatt hours. So we are talking about roughly 40 Teslas wired together deep inside the ship.
In terms of sheer energy capacity, yes. In terms of weight, it's much, much more dense. That battery bank alone weighs 35 tons.
35 tons of batteries. That is a massive deadweight penalty for a ship. You are essentially hauling 35 tons of lithium and casing around the world with you everywhere you go. What is the operational payoff that makes that weight worth it?
The payoff comes down to two main operational modes: peak shaving and hotel mode.
Let's break those down. What is peak shaving?
Peak shaving is purely an efficiency play. Diesel engines, especially the massive Caterpillar generators that Luminosity uses, they hate running at variable loads.
They like a steady rhythm.
Exactly. They want to run at exactly 80% load, steady state, forever. That is where their fuel burn is most efficient and where they produce the least soot.
But on a luxury yacht, the power demand is constantly spiking and dropping.
All the time. The chef turns on all the induction ovens, the air conditioning kicks into overdrive because the sun came out, the captain fires the bow thrusters to maneuver. Instead of constantly revving the diesel engines up and down to meet those spikes, the batteries absorb the demand.
Ah, so the batteries act as a buffer.
Yes. The batteries handle the spikes, and the engines stay completely flat and happy.
So you get much better fuel economy and far less wear and tear on the engine liners.
Correct. It reduces maintenance costs significantly.
Right.
But peak shaving is just the practical side. The hotel mode is the real luxury sell.
Hotel mode, meaning when the ship is acting as a hotel at anchor.
Right. With 3 megawatt-hours of stored power, Luminosity can shut down all 6 of her diesel generators entirely. She can sit at anchor for 12 straight hours, 0 emissions, 0 exhaust fumes on the aft deck, and most importantly, 0 noise.
12 hours, so you can sleep through the entire night without a single engine running. That silence is the ultimate luxury asset.
It really is. In what they call the noble areas, the master cabin, the main salons, the noise floor drops below 35 decibels.
35 decibels.
That is quieter than a library. Honestly, most HVAC systems in high-end land-based homes are louder than 35 decibels.
And this electric capability also allows them to enter restricted environmental zones, right?
Yes, this is us zones, sulfur emission control areas, or places like the protected fjords in Norway, where local governments are beginning to completely ban combustion engines to protect the ecosystem.
So this giant yacht can just glide in silently.
Exactly. It can navigate electrically, driven by her twin ABB azipods, without emitting a single gram of CO2 locally.
Let's touch on those azipods briefly because you mentioned them earlier as being distinct from traditional propeller shafts.
Right. If you look at traditional marine propulsion, you have a huge diesel engine bolted inside the hull, a long, straight steel shaft poking out the back of the boat, and a fixed propeller on the end.
And the main problem with that is vibration.
Massive vibration. The engine vibrates the hull structure, the rotating shafts vibrates the bearings, it all travels up into the guest cabins.
But Luminosity uses diesel electric.
Yes. The diesel engines on board are just power plants. They don't connect to the propellers at all. They just generate electricity. That electricity is sent via cables to the azipods.
And azipods are...
They're electric motors housed inside torpedo-shaped pods that hang completely outside the hull underwater. The propellers are attached directly to those submerged pods.
So the actual source of the propulsion vibration is submerged in the ocean, rather than bolted to the floorboards beneath your bedroom.
Exactly. The water dampens the vibration. Plus, the azipods can independently rotate 360 degrees.
So you don't even need a traditional rudder.
No rudders, and you often don't even need stern thrusters. You get incredible maneuverability. It's a far more elegant hydrodynamic solution, albeit a significantly more expensive one to install and maintain.
Before we move off Luminosity, I really have to ask about the art integration mentioned in our sources. The moving forest. Is this just a fancy, oversized television screen?
It's much more integrated than a TV. It is a 370 square meter digital panel installed in the main stairwell that spans multiple decks, and it uses advanced motion sensors.
So it tracks the guests?
Yes. As you walk past the panel, the digital trees on the screen physically sway in response to your movement, as if you are generating a breeze.
That's wild. And the breathing flowers?
That's physical kinetic art.
Yeah.
There are 264 motorized Korean magnolia flowers mounted on the wall. They physically open and close as guests pass by them.
It sounds like they were genuinely trying to make the boat feel like a living, breathing organism.
That fits the entire theme perfectly. Luminosity. Light, energy, life. It is a very tech-heavy, almost sci-fi interpretation of nature.
Okay, so Luminosity is the high-tech, fragile, glass-encased hybrid sister. Let's pivot to the second sister of the Giga season, IJE. 108 meters long, the longest of the trio.
IJE is really the antithesis of Luminosity in many ways. If Luminosity is a delicate floating glass villa, IJE is a floating Land Rover Defender.
Built for an owner who apparently wanted to take his family anywhere on the globe.
A truly global explorer.
The exterior design was done by RWD, a British firm, and looking at the profiles, it looks so much cleaner than Luminosity. Less jewelry, fewer distracting lines.
Much cleaner. The central design prompt for RWD was minimalism. But achieving true minimalism on a 108-meter scale is incredibly difficult.
Because of the regulations, right? You have so much mandatory safety and operational equipment.
Exactly. You have mandatory life rafts for dozens of people, massive cranes, air intake vents, exhaust stacks, wing stations for the captain to dock. You can't just wish that equipment away for the sake of a clean sketch.
So how did RWD hide all that clutter?
They used what the designers call the cloak effect. The superstructure of the yacht is designed to physically wrap around the exterior walkways and the utility decks.
So it hides the working parts of the ship.
Right. For example, the life rafts are recessed deep behind flush-fitting hydraulic panels in the bulwarks. When you look at the profile of IJE from a distance, you don't see any of that operational clutter. You just see these incredibly long, pure, uninterrupted horizontal lines.
And what about these Monterey wings mentioned in the design brief?
That is a highly specific optical trick RWD employed. They are fashion plates, basically structural extensions of the white-painted superstructure that sweep down from the upper deck, but they intentionally stop just short of touching the main deck bulwark below them.
Oh, so there is a gap.
Yes.
Yeah.
They don't connect. So from the outside, the upper decks appear to just float above the main hull. It breaks up the massive visual bulk of a 108-meter ship, making it look much lighter and sleeker than a vessel of this volume actually is.
Okay, let's talk about her actual explorer credentials, because let's be honest, every yacht over 50 meters claims to be an explorer these days.
The marketing term is definitely overused.
Right. What makes IJE actually capable of safely crossing the Pacific Ocean while others just look the part?
It comes down to two things: extreme range and mechanical redundancy. She has a certified range of 6,500 nautical miles at a cruising speed of 14 knots.
6,500. That is easily transoceanic.
It's transoceanic with a massive safety margin. You could cross the Atlantic and almost cross back without stopping for fuel. But the key piece of Explorer hardware here isn't just the big fuel tanks, it's the shuttle pump jet installed in the stern.
A pump jet? Is that essentially a stern thruster?
It can act as a stern thruster, but it is fundamentally a pump jet. Think of it like a massive jet ski propulsion system on steroids.
Yeah.
And it's mounted completely flush with the flat bottom of the hull.
It's an electric unit, right?
Yes, a 500 kilowatt electric pump jet.
So what is the tactical advantage of a pump jet over a traditional propeller when exploring remote areas?
Two major advantages. First is shallow water capability. Because the pump jet is flush with the hull, you don't have a massive bronze propeller hanging 3 meters down, waiting to strike an uncharted reef in the South Pacific.
That makes sense. You can sneak into shallower anchorages safely.
Exactly. Second, and this is the most critical feature for IJE, is DP, dynamic positioning.
We hear about DP a lot in commercial offshore vessels, like oil rig supply ships. Explain how it works for a luxury yacht for the uninitiated.
Okay. Imagine you reach a remote atoll, and you want to stop the boat to have lunch or launch the tenders to go diving. Traditionally, you drop a massive anchor.
Right.
But a 100-meter ship has an anchor that weighs tons, and it drags a massive steel chain across the seabed as the boat swings in the wind.
Which is devastating to the environment.
If you were in the Great Barrier Reef or a protected marine sanctuary, that anchor chain literally destroys centuries of coral growth in minutes.
You are basically bulldozing the exact reef you traveled across the world to see.
Exactly. It's incredibly destructive. With dynamic positioning, you never drop an anchor. The ship's computer connects to a network of GPS satellites and takes direct control of the main propellers, the bow thrusters, and this shuttle pump jet.
And it just holds the ship there.
It constantly makes automated micro-adjustments to thrust and steering to hold the ship in an exact latitude and longitude, fighting the wind and the ocean current automatically.
So the boat is literally hovering over the reef.
It hovers. IJE can stay in a precise position for days without ever touching the fragile seabed below. And that pump jet is crucial for this because it can direct its thrust 360 degrees instantly. It gives the computer a level of fine-grain, multi-directional control that a traditional main engine shaft just cannot provide.
And it can also use that pump jet to creep along electrically at 8 knots, right?
Yes, silent, low-speed electric cruising without firing the main MTU diesels. It's perfect for sneaking up on marine life or navigating through a quiet anchorage at dawn.
That really validates the Explorer profile. It's not just aesthetic. You also mentioned launching tenders. The notes say the garage on IGE is designed to hold 2 40-foot tenders.
Yes, 2 12-meter tenders.
That is not a tender. A 40-foot boat is a serious cabin cruiser in its own right. Most normal people consider a 40-footer their main yacht.
Very true. Most super yachts actually have to tow boats of that size behind them on a long line because they physically cannot lift them out of the water. IGE carries 2 of them, side by side, right on her enclosed foredeck.
The physics of lifting a 40-foot boat, which must weigh, what, 10, 12 tons?
Easily.
Lifting that from the open ocean up onto the high deck of a rolling ship? That sounds incredibly sketchy.
It is widely considered the most dangerous routine operation you can do on a super yacht. You suddenly have a massive, multi-ton pendulum swinging in the air above the crew. If the mothership rolls on a wave, that tender becomes a wrecking ball.
So how does Benetti solve that?
To manage this safely, IJE is fitted with reportedly the largest single-point lift crane ever installed on a private yacht.
A single point lift, meaning one cable.
One massive lifting point rather than a cradle. The engineering of that crane boom, the sheer power of the hydraulics, and the active motion dampening systems required to prevent that swing that was a massive sub-project for the shipyard all on its own.
And once you launch those tenders, what is left on the yacht? What are the amenities for the guests who stay aboard?
Well, she has a dedicated subterranean nightclub, a full cinema, and over 1,000 square meters of pure exterior deck space. So you're not exactly roughing it while the tenders are away.
Incredible. Okay, so IJE is the long-range, self-sufficient, heavy-duty beast. Now we arrive at the third sister of the Giga season, Lana, or as she's currently known, MAR.
Right. Lana is a fascinating contrast. Because while Luminosity is clearly a high-tech engineering demonstrator and IJE is a very personal, family-oriented global adventurer, Lana feels like a highly polished commercial product.
It's built for business.
It was designed from the keel up to absolutely dominate the ultra-high-end charter market.
And the numbers we have definitely support that ambition. A reported 1.8 million euros per week base rate.
Plus expenses.
Plus expenses, right? Fuel, food, dockage. Who on earth pays that kind of money for a one-week vacation?
People who specifically want the democratic luxury that Lana was engineered to provide.
Democratic luxury. I have to say, that sounds like a ridiculous oxymoron when we are talking about the top 0.001% of global wealth.
It sounds absurd, I know. But it solves a very specific, very real problem in the charter industry. Let's say you and I are billionaires.
Sounds great.
And we decide to charter a super yacht for the summer with 3 other billionaire couples. We're all equal friends, and we split the €2 million bill evenly. We get on board the boat. I drew the long straw, so I get the owner's suite. It's 100 square meters, panoramic views, private terrace.
Okay.
You get the primary VIP suite, which is pretty good. But the other 2 couples, the ones who paid the exact same share as us, they get shoved into the standard guest cabins down on the lower deck near the engine room. They're sleeping in a room half the size with tiny portholes instead of windows.
Yeah, I can see how that creates conflict.
It completely ruins the trip. Resentment builds. Lana solves this structural flaw in yacht design by featuring 7 VIP staterooms, all located on the main deck.
7 equal suites.
Yes. They are all virtually identical in layout, quality, and volume. They all have massive hull windows. No one feels shortchanged. It's a brilliant layout strategy for a charter vessel.
And the ceiling height in those suites, the sources emphasize it's 2.7 meters.
Nearly 9 feet tall.
That is architectural scale. Usually on a boat, you are fighting for every single millimeter of vertical space.
Always. Because every inch of height you add to the decks raises the ship's overall center of gravity.
The VCG,
Yep.
vertical center of gravity.
Right. And a higher VCG drastically affects the metacentric height, which makes the boat less stable. It rolls more aggressively in the waves.
So how did Benetti give Lana 9-foot ceilings without making the boat dangerously unstable or uncomfortable?
A combination of ballast and a very wide beam. She's a very wide boat for her length, and they definitely had to compensate for that high profile with significant active stabilization systems.
The 4 Naiad fins?
Exactly. 4 massive underwater fins that constantly articulate to counteract the roll of the ocean and keep the pool flat. The end result is that when you walk around inside Lana, the feeling is of a land-based palace. You don't subconsciously feel like you're in a confined marine environment.
And the owner's deck, if all the guests are equal, where does the actual owner stay when they aren't chartering it out?
The owner gets a massive full-beam suite on the bridge deck. It features private fold-out balconies on both the port and starboard sides. It offers absolute privacy, completely separated from the guest flow, even when the yacht is full.
Let's talk about that flow. In high-end hospitality, the service needs to be entirely invisible. How does Lana's layout actively facilitate that level of service?
This is the real puzzle of the general arrangement, or the GA. Lana operates with 34 crew members to serve just 12 guests.
That ratio is almost 3 crew for every 1 guest.
Yes, but as a guest paying €2 million, you don't want to see 34 people constantly running up and down the main stairs. It ruins the illusion of privacy. So Lana features a highly complex, dedicated network of service corridors, hidden pantries, and crew stairwells that are completely separated from the guest areas.
So a stewardess can grab a fresh set of towels from the laundry deck, go up 3 levels, and enter a guest cabin to make the bed without ever walking through the main guest lobby.
Exactly. Or the chef can move a multi-course dinner from the main galley to the upper dining deck entirely behind the scenes. It creates this magic experience where your cocktail glass is always mysteriously refilled and your bed is perfectly turned down, but you almost never saw the person doing the work.
It closely mimics the hidden servant passages of those massive Edwardian estates we see in history.
Exactly like that, but digitized and optimized for modern marine efficiency.
And for the guest comfort inside those cabins, the notes specifically mention box-in-box construction. Is that a literal description?
It is very literal. It is the ultimate noise and vibration attenuation technique.
How does it work?
Instead of taking the floorboards and the decorative wall panels and bolting them directly to the steel frame of the ship, which is the standard way to build a boat, you essentially build a self-contained structural box. That box is the guest room.
Okay.
And then you mount that entire box inside the steel hull using highly calibrated rubber isolation dampers.
So the room is literally floating independently inside the structural shell of the ship.
Correct. So the ship's main engines or generators might be vibrating at 50 hertz. That mechanical vibration travels rapidly through the rigid steel hull. But when that wave of energy hits those rubber mounts, it is absorbed and dissipated.
It never transfers into the floorboards of the cabin.
Exactly. It breaks the acoustic bridge. That is how you get those whisper-quiet, recording studio-level acoustic ratings while cruising at 15 knots.
It sounds incredibly expensive and complicated to engineer.
It is. It eats up valuable interior volume, it adds tons of weight, and it slows down the build process. But for a vessel commanding those top-tier charter rates, it's absolutely mandatory. You cannot have rattling panels.
What other amenities justify that price tag?
The beach club is spectacular. It's 120 square meters at the waterline, featuring huge folding terraces that act as balconies directly over the sea. It has a full hammam, a professional gym,
And the pool.
a massive heated pool situated perfectly on the sun deck. It's a major reason she's been so successful on the charter market, reportedly hosting high-profile figures like Bill Gates and Beyonce.
So we have dissected the trio, the fragile glass hybrid of Luminosity, the rugged global explorer of IJE, and the hyper-efficient charter hotel of Lana.
The Giga Season sisters.
But now we have to answer the biggest question of this whole deep dive, the verdict. How on earth did a yard like Benetti manage to build all three of these massive, complex, custom 100-meter vessels at the exact same time?
This is where the story shifts from naval architecture to pure industrial logistics. Because Benetti had to completely reinvent themselves. They invested over 15 million euros just to prep the Livorno shipyard site.
15 million just on infrastructure before cutting steel.
Yes, they built two completely new, massive construction sheds. We are talking 58.5 meters wide and 137 meters long.
Why do you need a shed that big? When you see commercial tankers or cruise ships being built, they're usually just built outside on a slipway, exposed to the elements.
It comes down to finish quality. To get that flawless, mirror-like finish on the exterior paint of a superyacht, or to strictly control the ambient temperature and humidity for the complex glues and epoxies, like the ones holding Luminosity's load-bearing glass together, you absolutely need a controlled indoor environment.
You can't have dust blowing in off the port or sudden rainstorms ruining a paint layer.
Exactly. Plus, they had to install heavy-duty gantry cranes with a 40-ton lifting capacity and a massive ship lift capable of handling over 2,500 tons just to get these finished boats into the water safely.
And the logistics of flying people in.
They even installed an ENANC certified helipad right there at the shipyard. That allowed the billionaire owners, their design teams, and crucial technical experts to fly in directly for rapid decision-making. Time was the enemy.
What about the manpower, the logistics of coordinating the human element? The notes say peak capacity hit 1,800 people.
Yes. The Giga season required over 2 million man-hours of labor. At the absolute peak of construction, there were 1,800 people, representing over 100 different specialized suppliers, all working on the Livorno site simultaneously.
Just coordinating where those 1,800 people park their cars and eat lunch sounds like a nightmare. How do they organize the actual work?
That is where the Quinn Consortium comes in.
The Quinn Consortium. Who are they?
It is a highly specialized research group spun out of the University of Pisa. Benetti realized that traditional management wasn't going to cut it, so they brought them in to implement essentially an AI-driven predictive logistics model.
Why was traditional management not enough?
Look, when you're building one 50-meter boat, a good project manager can run it with Gantt charts, spreadsheets, and daily meetings. But when you're building 3 highly custom 100-meter vessels side by side, the complexity curve goes exponential.
Give me a concrete example of that kind of compounding complexity.
Think about fitting out the interiors.
Yeah.
You have plumbers, high-voltage electricians, finished carpenters, marble installers, carpet layers, and painters. They all need to perform precise work inside the exact same 20-square-meter guest cabin.
Right, and they can't all be in there at once.
No, it's a strict sequence. If the plumber is delayed by 2 days because a valve didn't ship, the carpenter cannot install the wall panels. If the carpenter is delayed, the carpet layer is standing in the hallway waiting. Now multiply that single bottleneck by hundreds of cabins spread across 3 different massive ships.
It's a complete collision course. The delays would compound until the whole shipyard grinds to a halt.
Exactly. So the Quinn Consortium's AI ran a 4-dimensional simulation of the entire build.
4-dimensional, meaning 3D space plus time.
Yes. It digitally models the physical 3D space of the ships, and then it simulates the entire construction process 3 years into the future. It can predict conflicts before they happen in reality.
So the computer says, hey, in 18 months, on deck 4 of IJE, you are going to have a physical space clash between the HVAC ducting team and the decorative ceiling installers.
Precisely. And because you know that 18 months in advance, you stagger the scheduling or alter the ducting route digitally today. It fundamentally turns shipbuilding from a reactive craft, where you say, oh no, we have a problem, let's tear this wall down, into a predictive, highly optimized manufacturing process.
Which is absolutely necessary when you have to install things like, what does the outline say? 500 kilometers of electrical cabling just on Luminosity alone.
500 kilometers. That requires military-grade planning.
It really sounds like the fortification of the superyacht industry, bringing automotive assembly line precision to custom luxury craft.
That is exactly the conclusion you have to draw. The Giga season proved that a shipyard can actually industrialize the production of ultra-luxury assets without losing the custom feel.
Because they shared underlying platforms.
Yes. Benetti used standardized technical platforms for the hulls. They utilized very similar structural engineering principles, propulsion layouts, and piping routes below the waterline. But they heavily customized the topsides and the interiors for each owner.
So they aren't totally unique snowflakes from the keel up. They share unseen DNA to save immense amounts of engineering time and cost.
Exactly. The engine room layout, the main structural bulkheads, the technical spaces, these can be largely replicated. This allows the shipyard to reuse verified engineering data rather than starting from a terrifyingly blank sheet of paper every single time an owner signs a contract.
Which drastically lowers the risk of catastrophic failure.
Drastically. And that shared unseen DNA is exactly why Benetti succeeded, where a lot of industry analysts predicted they might fail. They successfully combined Italian design flair and bespoke craftsmanship with rigorous German-style industrial efficiency, all aided by university-level artificial intelligence.
It really changes the entire global perception of the Benetti yard. They aren't just the stylish semi-custom option anymore. They proved they are a heavy industry player capable of taking on the biggest, most complex projects on the water.
They absolutely graduated to the big leagues. And these 3 sisters, Luminosity, IJE, and Lana, they are the diploma. They proved they could deliver 3 totally distinct identities: the high-tech hybrid, the global explorer, and the commercial triumph.
It's a massive shift in what we consider technically possible in marine engineering, using massive expanses of glass as a structural element, running a 100-meter vessel on hybrid batteries, and managing it all with AI.
It sets a new benchmark for the whole industry.
It does. Which leaves you, the listener, with a rather provocative thought to mull over as we wrap up this deep dive. We are witnessing the transition of yacht building from a bespoke, localized craft into a high-tech, AI-managed heavy industry. If shipyards are creating standardized tech platforms for 100-meter Giga yachts, similar to how Volkswagen shares a chassis between a Porsche and an Audi, are we seeing the automotivization of the Giga yacht industry?
That's a very real possibility.
Right. And if that's true, does this mean we're going to see a sudden explosion of 100-meter plus yachts on the water because the risk and cost have been mitigated? Or will the sheer logistical complexity and infrastructure requirements keep this kind of simultaneous production limited to a very rare, once-in-a-generation Giga season event?
It will be fascinating to watch the Dutch and German yards respond to this new reality.
It definitely will. Well, whether you prefer the fragile glass palace, the rugged global explorer, or the democratic layout of the charter boat, You have to respect the immense industrial hustle required to build them all at once.
Absolutely, is an undeniable engineering triumph.
That is it for this deep dive into the Benetti Giga season and the incredible logistics behind these massive vessels. We will be back next time with another close look below the surface of the world's most complex machines. Thanks for listening.
Did you enjoy our detailed analysis? Subscribe now and join our community of yachting experts. See you in the next video.